My name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. Welcome to my class. So today we are going to do a topic from the module DC Network Theorem, that is the problems on superposition theorem. So in the previous classes we have seen that what is the concept of superposition theorem, what is the utility of the superposition theorem, what are the steps we have for solving the superposition theorem, and we have seen the what is the limitations of superposition theorem. So here we will deal with the practical problems. A circuit will be given over here, and some values will be given of voltage source and current source and the resistors. So then we will try to solve those problems using the concept of superposition theorem. So let us start. Yes, so in this theorem we are going to do this points: equivalent resistance, voltage or current divider rules, source transformation, nodal voltage, mesh currents, and superposition. Now basically where we actually use this superposition theorem. So from the concept, from the previous class concept, that there we have done the what is theoretically a superposition theorem is. So there we have seen that so superposition theorem is applicable where two or more than two sources are present. Two or two more than sources means a circuit containing two voltage source or two current source, or one voltage source, one current source, or a combination of n numbers of source. That means for applying superposition theorem we have to remember that we have to we have a circuit which has at least two sources, then only then we can apply this superposition theorem. And then we know this is the steps by which we can find out the current and voltage of either branch. And we know that from the limitations of superposition theorem that superposition theorem cannot be used for the measurement of power, because that we have discussed that one, that superposition theorem is a linear circuit application based theorem. So it can, and power is not a linear quantity, so we cannot apply the superposition theorem for the power measurement. It can be used for the measurement of branch currents and branch voltages. So in the end, what is written over here: in a circuit having more than one independent source, we can consider the effects of the sources one at a time. So this is actually, here it is the lines telling that what is the procedure to solve the theorem. So let us just briefly see how what is the procedure actually we have for solving the superposition theorem for a very little manner, so that we can recap whatever concept we have taken in our previous classes, and then we go for the solution. Okay, so let us see. Yes, so there is a mathematical problem is given. So follow my pointer. So there is a set of two equations. Here they mean in middle there is a set of equations, and here also a set of equations. So three pairs of equations are there, and as you can see, in each pair of equations there are two variables, VA and VB. So from the rules of mathematics we know, if we have two unknowns, VA and VB, so to solve that we need two equations. Yes, we have two equations over here, so we can solve those problems mathematically, and we can find out the VA and VB value. Correct? So that means what, if we know the mathematical background to solve any function or any equation. So if any circuit, any mesh, any loop, if any node can be represented like this way, like a function, like a equation, then we can solve that one, and we can find out the result of that particular circuit. So this is I have given just for the to say that that equations, we have to make equations like this, and we have to solve those equations. Okay, this is just a motto that we what are the patterns of the equation that we have to make for this solving this superposition theorem. So these are the patterns where we there will be two equations where 1, 2, 3 components will be unknown, and we have to, as per the number of unknowns, we have to find out the we have to make the equations, and then after that we have to solve the equation. So what is written over there? Let us see. Mathematically, we can solve the simultaneous equation a piece at a time. If these equations are form a circuit, this math implies that we might be able to solve the circuit a piece at time. That means whatever I am telling, that a circuit, if it is can be represented like this equation pattern, then we can solve those equations and we can find out the solution. So let us come to the next slide. Okay, the superposition theorem. So just giving you a brief idea. So I'm just reading that what is written over here, and then I'm just little bit discussing with you what is that. So in a circuit having more than one independent source, we can consider the effects of the sources one at a time. That means I have already told what is the condition for applying superposition theorem. So one thing, main thing is that the circuit should have at least two sources, maybe voltage, maybe current. Now in the procedure of solution, there, as per the theorem is concerned, it is told that in the theorem that whatever is the number of sources, at a time we have to consider one source, and for that particular source we have to check what is the current flowing through each branch, and if we can able to find out what is the current flowing through each branch, we can find out what is the voltage across each branch, correct? So like this way, we considering each source at a time, and we can find out for what is the effect of one source in a circuit, and at the end if we sum up according to the direction of the current or according to the potential of the branch voltages, we can find out the branch voltage and branch current. Okay, so if a circuit has n independent sources, then we will have to solve n separate circuits. Is it easier? Perhaps. The resulting partial circuit will have one source and some resistor. We might be able to solve the partial circuits using the shortcut method we saw earlier. Each partial circuit may be very easy. So that means it is written over there. Yes, if a circuit has n numbers of source, we have to consider one source at a time, and like this way n step we have to follow for solving this kind of problem. And now we are going to see what is the shortcut method we have for using to solve any kind of superposition theorem. So we are discussing about that when we have to apply superposition theorem, that time we have to consider only one source, and we have to remove other also, maybe voltage, maybe current. So when we are removing a source from a circuit, so what we have to do with that terminal? Say we are discussing about, so for simplicity for now we are considering we have in the circuit we have a ideal voltage source and we have a ideal current source. Now the property of ideal voltage source is it has zero internal resistance, and the property of ideal current source is that it has infinite amount of internal resistance. Now the point is, as per the rule, when we have to remove some source from a circuit, we have to left its internal resistance into the circuit. Okay, again I am telling, when we have to remove any kind of source, maybe voltage, maybe current, from the circuit, we have to leave its internal resistance to the circuit. Okay, so now again remember, what is the internal resistance of ideal voltage source? It's zero. What is the internal resistance of ideal current source? It's infinite. So remembering these 2 points, and we have to leave its internal resistance in the circuit. Considering these 2 points, we are now going to see what we have to do if we remove a voltage source, what we have to do if we remove a current source. So just follow the presentation in the below section. Just follow my pointer. There is a voltage source. Now when we have to remove this voltage source, so ideal voltage source has zero internal resistance, that means no resistance is there, that means we have to make the terminal short. Yes, see, short circuited. Now in case of current source, So in case of current source, what we have to do? So in the ideal current source, what is the amount of resistance? Infinite. So when we have to remove current source from any branch, then we have to think about that we have to left over there infinite amount of resistance. So now what is infinite amount of resistance? So infinite amount of resistance means such amount of resistance through which current cannot flow. Through which current cannot flow if the terminal is open. So that means when we have to remove a current source, we have to make the terminal open, and open terminal always offers an infinite amount of resistance. So see, again in the presentation in the right hand side there, as you can see, so there is the current source. So when we are removing this current source, yes, see, this is open circuit. So very important to point, when we are removing voltage source, we have to make the terminal short. When we are removing current source, we have to make the terminal open. Okay, coming to the next slide. So if we go like as far the superposition theorem is concerned, so there we can say that, so for your simplicity, I have taken a circuit which contains a voltage source and which contains a current source. So I'm not going for the more details, just I'm telling you the how to solve. So we have to consider any one source. So in the step 1, it is considered Vs is present in the circuit, and the Is, that is the current source, is removed. So when current source is removed, so as you can see, that terminal is made open, and remaining thing that now we can use for uh, Vs source. Now we will find out through each branch what is the current value. Okay, so this is the first step. That means we have considered the voltage source and we have removed the current source, and after removing current source we have made that terminal open, and now through each branch, due to Vs presence, what is the current, what is the voltage, that we can find out. Okay, so this is all about the first step. Okay, this is the second step. That means now we are considering current source and we have to remove voltage source. Now what is the rule for voltage source? When we have to remove voltage source, we have to make that short. So we have made that short in the diagram, as you can see in the above diagram. Now we can apply directly the current division rule to find out the current passing through R1 and R2. So this is a direct rule, and also we can apply the voltage division rule to find out the voltage across each branch. So after doing that, at the end, see at 3, the complete answer is the sum of two partial answers. That means we are going to see, as per the potential, remember this one, as per the potential, we have to add or subtract the values. So here we are considering that what is the voltage across this R2. So in both cases we can find out that current is flowing from upward to downward. So here is a positive terminal and here is a negative terminal. So in both cases, for the both source, current direction is from upward to downward, so potential will be here higher, below section there is lower. So both are in same polarity, so we can directly add them, and there is the answer. Okay, so this is one example we had, very simple example we are doing. Now later on, after this, we are going to solve different kind of problems, so that you can very easily solve any kind of problems. Now go to the next slide. Yes, this is a summary whatever we have done. So I'm not going to for this reason, directly I'm coming to the problems. Conclusion not required, already we have discussed in the previous classes. Yes, this is a circuit I have given example number 2. So here what we have taken, that is uh, two voltage sources are there, Vs1 and Vs2. So deactivate Vs2, just reading the problem statement, deactivate Vs2, the result, no, sorry, my fault. For the circuit shown, use superposition to find the value of VR1. So that means we have to find out now that what is the voltage drop, across this R1. Okay, so what is the voltage across this R1? We can think that for due to this Vs1 some current is flowing, and when this current is flowing to this R1, there is a drop. Again, when due to this Vs2 due to that some current is flowing into the circuit again, and due to that again some current is flowing through the R1, and due to that some drop is there. Now two drops are there, so we have to add. Okay, so for that we have to, what we have to do, we have to apply the superposition theorem, and we have to solve those theorem. So here, as in the first step, we have to consider one source, so we are considering only Vs1. So follow my pointer over here. So only Vs1 is present, and this Vs2 is removed, and that terminal is shorted. Now see, from this positive terminal, follow my pointer. This, from this positive terminal, current will come out and it will come to this node, and it will both the direction, it will divide as per the resistance value. So what is the series parallel combination of resistance? So at this node, the series current is divided between R2 and R3. So we can say that, we can definitely say that this R2 and R3 are in parallel with that R1 in series. This is the amount of equivalent resistance we have. Now after that, if we do that, if we apply, if we want to find out that main current, that is the source current, then we have to Vs1 by R equivalent, then we can find out the main current, and then again apply the current division rule and find out the branch current, and then multiplying with that resistance value, we will get the voltage. So but for simplicity, what we can do, we can directly apply the voltage division rule. So what is the voltage division rule? See, over here we can see that VR1 is equal to R1, that means through which we have to find out the voltage, that one by the series parallel combination of the whole resistance. So what is the series parallel combination? R2 R3 parallel with that R1 in series, and this is the total voltage, the supply voltage. Just put the value and you will find out this 8 volt will be the first step result. Now in the next step, same thing we have to do for the next step. So next step, what we have to do, we have to consider this Vs2 and we have to remove this Vs1. So when we have removed this Vs1, so we can say that Vs1 uh, is like it is a ideal voltage source. We have to remove and we have to make the terminal short, and again we are using over here the voltage division rule. So what is that? Vr1 double bar is equal to R1 parallel with this R3 and R1 R3 parallel with this R2 Vs2. So from there we can directly find out the potential across the V1, correct? Now for your better understanding, see here the R1 location is shifted. Clear? So if the R1 location is shifted, then we can say that the previous step 1 and step 2 voltage are at the same polarity, correct? See, plus minus polarity in this step 2 and step 1, just check. So here also yes, there is a first plus, then there is a minus. Here also there is a plus, there is a minus. So both are in the same polarity. If both are in the same polarity, then it should be, it must be additive. So here the total voltage across this R1 is equal to VR1 bar plus VR1 double bar. So just adding them as per the potential, and the 8 volt minus 2 volt, that is 6 volt. So that is the answer. Okay, yes, this is another problem. So here, so this the statement is given for the this particular problem. For the circuit shown, use superposition to find the power being dissipated in R3. So what is the amount of power through R3, that we have to find out. So again the same method, we have to consider one source at a time. We have to remove the second one. If it is a voltage source, then after removing that voltage source, we have to make that terminal short. If it is a current source, after removing that current source, we have to make that terminal open. Okay, so that thing we are doing over here. So as there is a voltage source, we have removed that one. Follow my pointer, and it is, and the V1s is present, and the previous problem as we have solved, like that way we can find out uh, what is the equivalent resistance of the circuit. See here, how they have reduced. See this R2 and R5, they are in series, correct? So will make a series of them, and that thing is parallel with this R3, and this total thing is in series with R1. Getting my point? Again I am telling. So see, follow my pointer. From VS1 the current is producing, it is coming to this node. After this node it is dividing between R2 and R3. Whatever current is flowing through this R2, it is again flowing through this R5. So same current is flowing through R2 and R5. So they are in series, and the combination this R2 plus R5 is in parallel with this R3, and this whole combination, parallel combination, is in series with this R1. Okay, so this combination is written over here, and again applying the voltage division rule, we can find out the VR3. Okay, next, here also we are considering the VS2, and we have removed this VS1. So here also, as you can see, this R1, so now for this particular circuit, the main current will flow through this, follow my pointer, through R2, then coming to node it will divide between R1 and R3. Whatever current is flowing through R3, that will definitely flow through R4. So as the same current is flowing through R1 and R4, so both are in series, and that combination is parallel with this R3, and this whole combination is in series with this R2. So same way as we have done the first step, so that thing we have placed over here, and this again we have applied the voltage division rule to find out the voltage, and at the end we have just added this with them, because in both cases the polarity is same. So as it's both, that's why they are both additive, and the total voltage, as we can see, there is a 225 volt. Okay, and finally the power, that is the main expectation or the outcome from this particular problem. So what is the expectation? That is the power. So power formula is V square by R. So V means here the voltage across the R3 and the value of resistance by the R3. So we have put over here the values, and we can find out 31.25 watt is the answer. Yes, this is the next problem. So in this particular problem, see, it's just if we think what we are doing, example number 1, 2, 3, 4. So in those things, what we have done, we have just changed the considering the same concept, considering the same calculation method, we have just changed in the voltage, current source, branches. So that means we are going for the harder problems. Okay, as you can see, this is a larger circuit than previous ones. So now let us solve this kind of problem. So what is there? So let us first see what is the statement of this particular problem. So it is told that in the circuit, find IR3 with 3 sources, there will be 3 partial solution. Okay, so we have to find out the IR3. Where is the IR3? So that the current passing through this R3, follow my pointer, the current passing through this R3 is the current IR3 that we have to find out. Now just we think that but there are 3 sources. That means we have to consider 3 sources separately, and after that we have to sum up. We have to sum up the current value as per the direction. Now, when we have to consider for the solution case, as we know, the concept of superposition theorem is we can consider only one source. So as we can see over here, we have considered the voltage source Vs, and we have removed the both current sources, because as per the rule is concerned of superposition theorem, you can consider only one source. You can consider only one source. Repeatedly I am telling you, can consider only one source, and all other source must have to be removed. So here first initially we are considering voltage source, and we are removing this to current source. So when we are removing current source, the terminal is open, so the circuit is reduced to the smaller one. Okay, so here we are just this is circuit, and one thing one thing is there, that is that a voltage source with series resistance. Just check this section, follow my pointer. The voltage source with a series resistance, this R1. The combination of these two can be converted a current source with a parallel resistance. This is known as the source conversion. So just we have just recapping the previous concept that we have done already. What is source conversion and how to do. So here this things it is done that the voltage source is converted so that the current the calculation can be much simpler. So we actually do this for the simplicity of the circuit calculation. So the main aim of this volt source transformation from voltage to current or current to voltage, that is the main simplicity of the calculation or the circuit for better understanding of the circuit. So but remember, the property of circuit should not be changed. Okay, so yes, the source current it is given by VIS is equal to VS is by RS. Yes, the current source value is now this one, and this series resistance will be in parallel with this one. Okay, so now the total current, sorry, so this is the current I3 bar, so that is equal to current division rule they have applied. So see, as you can see, these two are in parallel, these two are in parallel. With that, these two are in series, and this whole combination is, this series combination is parallel with this two one. So that formula is written over here. Okay, so we just applying the current division rule. The current division rule is stating that the total current, that total incoming current, here total incoming current is the IS, this one, this IS is the total incoming current, IS bar, and total incoming current into opposite branch current, where what is the opposite branch current. Okay, and then find out the branch currents. So coming to the next, so in the next case we are considering that IS1 source we have considered, and then as per that we have find it out the series parallel combination, and after finding out that, um, here we are finding out the branch currents. So these are the branch currents. So first, so R1 to 4 is equal to R2 and R4. This R2, and see here the current is coming, then it is dividing, correct? So when it is dividing between R2 and R4, same current is flowing. Okay, this is parallel, so this current is coming, it is dividing between this, and this current is flowing like this. Okay, so this is a series parallel combination. So yes, for this particular IS1, the IR3 double bar current is 11 milliampere. So like this way, so same method we are following over here also. Here we are just applying the current division rule for finding out the current passing through this R3, and at the end, as per the direction, we are going to add the current values. See, just check. Okay, this is the first source. For the first source, it is the direction of IR3 bar is from left hand side to right hand side, correct? For case 2, the current direction is IR3 double bar is from left hand side to right hand side. Okay, both should be added then, as both has the same direction. Yes, for the source 3, the direction of current, actually it is wrongly mentioned over here, it should be opposite. So as it is, as the direction of current is this, so definitely the current will flow like this. So this is actually the wrong direction mentioned in the picture, my mistake. So so actually the direction is opposite. So IR triple bar will be the negative of this 2. See, IR3 triple bar, yes, see, this is negative as the direction is opposite. So like this way we can solve any kind of problem on superposition theorem, where there may be a single, two source, three source, four source. Remember, always we have to consider one source, and for that particular source we have to find out the voltage and current values, and then at the end we have to, as per the direction, we have to add. Okay, so like this way any problem on superposition theorem can be solved. Okay, I think you are now able to understand what is superposition theorem, how we are going to solve the superposition theorem. Okay, thank you.